So here we have in the question number 5 a bivariate PDF for the discrete random variables x and y with the value 0.2 del x del y plus 0.3 del x minus 1 del y plus 0.3 del x del y minus 1 plus c equal to this. Now this 0.2 plus 0.3 plus 0.3 plus c should be equal to 1. So the value of c can be found out straight away from that. So we'll get 0.8 plus c equal to 1, and that is that uc is equal to 1 minus 0.8, and that will just give you c equal to 0.2. Similarly, the PDFs for x and y can be written as fxx is equal to integral of fxy x comma y dy with the limits minus infinity and plus infinity over here. So when you try to integrate this with respect to dy, then the del y and del y minus 1 in all these four terms will be equal to 1. It will become equal to 1 because integral of del is equal to 1. Integral of del is equal to 1. And hence, we are going to get the 0.2 plus 0.3 del x, that is 0.5 del x, 0.3 and the 0.2 del x minus 1, and that will be again 0.5 del x minus 1. Similarly, fyy will be equal to minus infinity to infinity f of xy x comma y dx. Now dx integral with respect to dx will make the del x minus 1 del x minus 1, and this del x to become equal to 1. Okay, that will become equal to 1, and the other things, other terms are going to remain as it is. So therefore we are going to get, so del x is equal to 1 means del y will have here, del y will have here, 0.2 plus 0.3 will give 0.5. Del y minus 1, del y minus 1 will be as it is, so therefore 0.3 plus 0.2 is equal to 0.5, and hence we are going to get this term. Then the capital F of x, y, x comma y, okay, this quantity will be what you call, we need to find the value where 0 less than x less than 1 and 0 less than y less than 1. So that will be only the first point will exist there, and that will give us the value which is equal to 0.2. Okay, we want it between 0 to 1 and 0 to 1. There's no equal to sign there, there's only less than sign there. So only this point is going to occur there, so therefore it will become 0.2 between 0 and 1, right? Then f of xx, the cumulative distribution function of a single variable, will be just integration of this. So integration of del x will be ux, integration of del x minus 1 will be ux minus 1. Similarly, fyy, cumulative distribution function, will be integration of the PDF, and integral of the del y will be equal to uy, integral of del y minus 1 will be equal to uy minus 1. Now, if you multiply, what you call these two quantities, if you multiply these two quantities, will you get back this itself, which is there here, is the question. So if you really see that, then it's not equal to f of xy, x comma y, therefore xy are not independent. Even otherwise, you can say that if you multiply these two, are you going to get the value which is equal to 0.2? No, you will not get. Hence, again, they are not independent. So either way, for independence, this should be equal to multiplication of these two, and this should be equal to the multiplication of these two. Now let us come to the ninth problem. F of xy, x comma y equal to 1 by 1.9079 pi exponential minus x square minus 0.6 xy plus y square divided by 1.82 for both x and y between minus infinity to plus y. We need to find the PDFs for x and y, and we need to check whether the 3.12 is satisfied at all, and also whether x and y are independent. So now again, for this, again we'll have to separate it out as two different squares. So if you put it as two different squares, so that's what he's doing it here. X square minus 0.6 xy plus y square is equal to, you need to divide this by 2, and then you'll get 0.3. So x minus 0.3y whole square, and 0.3 square will be 0.09. 1 minus 0.09 will become 0.91 to balance it out. Okay, to balance it out, you'll get 0.91 y square. Okay, so this y square is broken down into two parts. One equal to this divided by 2 square. This divided by 2 square will be 0.3, 0.6 divided by 2 will be 0.3, 0.3 square will be 0.09. And if you write x square minus 0.6 xy plus 0.09 y square, then we will get x minus 0.3 y whole square, right? And the rest of the thing, that is 1 minus 0.09 will give us 0.91 y square. So this, to find the PDF of x and y, such as fyy, we need to write it in this format over here. Okay, and then you can easily, differentiate it with respect to the value of x. So at that time, you can take the y out. At that time, you can take the y out, and only the x you differentiate, and you'll get the value, which is something like this. Similarly, you will get for fxx equal to 1 by root of 2 pi e to the power of minus x squared by 2. Now, again, if you try to integrate this, each one of this over here, this within the range of x and this within the range of y, which is again minus infinity to plus infinity, either way, you are going to get a value equal to 1, because this integral is really equal to 1. Also, if you try to multiply f of x, y and f of xx, you are not going to get this. So therefore, the xy are not independent. Okay. Let us come to the question number 11. In the figure is shown the region, which is a triangular region over here in the xy plane, where the bivariate PDF f of xy is equal to c. Elsewhere, the value of PDF is 0. So within this region, it is c. Outside this region, it is 0. What value must c have? Okay, what value must c have? Evaluate f x y 1 comma 1. Find the PDFs for both the variables x and y. Are these values x and y independent? So f of xy 2 comma 2 will be equal to minus 2 to 2, and here it will be x to 2, minus 2 to 2, because the value is same throughout this. Okay, whereas here it is x to 2, because it might be varying at that particular point. If a point is here, it will be totally a different place with different value, that is x to 1 dy dx. Oh, sorry, x to 2 c dy dx. So this is going to, if you integrate this over here, right? If you integrate this over here, you'll get the value, what you call one side x, and the other side you can get the value 2, that is 2 minus x. The value 2 minus x into c, and again you integrate once more, totally you'll get the value here as 8c. Okay, you'll get the value of as 8c, and that will give c equal to 1 by 8. So total value for this f of xy should be equal to 1. Then f of xy 1 to 1, here it is 2 to 2, therefore it is 1, whereas here it is 1 to 1. So we need to write the value of f of x y, that is equal to c 1 by 8 integral minus 2 to 1, because the what you call upper limit is 1 over here, the upper limit is 1 over here, and therefore this is 1. So if you integrate that, and then you will get 9 by 60. Then the probability density function will be 1 by 8 integral x to 2 dy, and that will give us 1 by 8. If you find the value of this integral, it will become 2 minus x for the range of minus 2 less than x less than 2. Similarly, fyy will be 1 by 8 minus 2 to y dx, that is 1 by 8 y plus 2. If you differentiate this, this will become x with the limit y and minus 2, and that will give us y plus 2. Okay, so if you multiply these two, you are not going to get back the value which is equal to C. F of xy should be equal to the value which is C. You are not going to get back the value of C there, and hence it is not the what you call x and y are not independent variables. Let us take another example. A bivariate random variable has the following: c of x plus 1 whole square, y of y plus 1 whole square. This is a CDF. Please note that we have CDF. Till now, you are taking the PDF, right? Now we are writing the CDF. So CDF is given over here for the range of value of x between -1 and 4, and for the range of value of y between -1 and 2. So what is the value of the C? What is the value of the C there? So range of values is given there, -1 to 4 for x, -1 to 2 for y. That is the region R. And f of x, y, 4, 2. Okay, this value should be equal to 1 because that gives us the full probability. That is equal to C into, x is 4 plus 1 whole square, that is 25. Then y is 2, that is 2 plus 1 whole square, that is 9. And that will give you 225 into C. So C will be equal to 1 by 225. Then we must find the bivariate PDF, that is small f of xy, x comma y, and that is nothing but the integration of this function the differentiation of this function over here with respect to dx and dy. So that is dou square, dou x, dou y of the whole thing which we have written over here. C is now 1 by 255, therefore it is already written there. Then the x plus 1 whole square is as it is, y plus 1 whole square is as it is. And that will get it as 4 by 225, x plus 1 into y plus 1. Then fxx and fyy is what we need to find. And that is fxx is equal to fxy, x comma infinity, but we should not take infinity because the maximum value of y is from -1 to 2. Therefore, we will take here 2. So therefore, we'll get 9 by 255 multiplied by x plus, x plus, this is x plus 1 square. Okay, x plus 1 square between -1 half of less than x is less than -1 less than x less than 4. Similarly, fyy will be fxy infinity comma y, and again we can't write infinity over here because the upper limit for x is 4, and that is what we are writing over here. Substituting this 4 for x over here, you'll get 4 plus 1 square, that is 25. So 25 by 255 into y plus 1 square within the range -1 less than y less than 2. So p of x less than or equal to 2 intersection p of y less than or equal to 1 will just give you the value of f of xy 2 comma 1. This value is nothing but f of xy 2 comma 1. That will give 1 by 255 into 9 into 4. That will give us 4 by 25. Then if you see there, f of x and f of y, these two things, if you multiply these two things, then you'll get 9 into 255 divided by 255 into 255, that will give 1 by 255. X plus 1 square multiplied by y plus 1 square, and that is what we have here also because c is equal to 1 by 250. So therefore, because of the reason that fxx and fyy is equal to f of xy, x comma y, we say that xy are independent. We say that xy are independent. So with this, we come to the end of this particular topic, and we'll take up the bivariate expectations in the next class. So I will rename what you call the